Okay ji, this video pertains to two concepts that we'll basically be dealing with. One is that the return type of a function would also be a struct, and we'll illustrate this with the help of an example. And the second one is the access modifiers, and we'll come to that point. So these are the two things that we'll cover in this video, and probably we'll move on to the classes in the next discussion. Okay, so let's take an example here. I'll share this slide with you. Okay, so here is a function that we need to write down. The function is said that suppose you have got 2 points P1 and P2, and they have got two coordinates. P1 has got x and y coordinates, and P2 has also got x and y coordinates, and we want the addition of these 2 points. The addition of these 2 points would mean here is that the x of P1 adds to x of P2 and gives you a new value of x, and y of P1 adds to y of P2 and gives you a new value of y. And the new value which you get after addition for x and y, that is also a struct. So if P1 is a struct and P2 is also a struct, if you add them the way I've just given you the example, you get another struct. Okay. There could be multiple variations here. Here we are dealing with addition. We can also think of multiplication. So we can say that, okay, multiplication of two struct or 2 points would mean that x and x, the corresponding x values, get multiplied, and as a result you get a new value of x which belongs to P3, which is a new struct. So we need to write down a program which which takes in P1 and P2 and returns P3, where P3 is also a struct, right? So let's try to code this. I'll share the coding environment with you. So this is an online IDE that I'm actually using here. Okay, and let's just try to write down a piece of code that could do this type of stuff. Okay, so let me just start by writing down the essentials of a struct. That includes, okay, so that includes primarily the same code that we were using earlier this in our video. So we are defining a struct point, and there are two, let's say, coordinates for that, x and y. The point is name of the struct that we have defined. Then we have defined a default constructor here that actually sets the value of x and y equals to 0. Then there are two setter functions here. One sets the value of x, the other sets the value of y, and we have already discussed this in the previous video. Then we have got the getters. One gets the value of x and the other gets the value of y. So these are primarily, and we haven't really introduced the parameterized constructor here. Okay. Now the next thing that we want here is that we want to write down a function that returns another struct by adding the corresponding values. And for this we can actually write down this function as is written here. So this is function add. The return type of this function is point. Okay, so the return type is also a struct, which is point, and it takes in two instances of point, one pertaining to point 1 and the other one pertaining to point 2. And what is this doing? This is actually adding the corresponding values of x together and the corresponding values of y's together, and that's being assigned to a new point struct which is called r, which is defined within this function add. So r डॉट x में आप स्टोर कर लेते हैं और r डॉट y में जो एडिशन ऑफ y's हैं वो r डॉट y में आपने स्टोर कर ली, और जो एडिशन ऑफ x हैं वो r डॉट x में आपने स्टोर कर लिए, and then you are returning r. Now r is also a struct of type point. So that's why line number 48 is important. Here you are actually defining the return type. So the return type could also be a struct. So this is what has been defined as a function, and this function has been defined outside the struct definition, right? Okay, so let's just write down the main program and initialize some of these values and then see के कैसे ये function काम करते हैं. Okay, so here we have defined a point P1 which is a point struct का एक instance है P1 which is point 1, और फिर point 2 which is representing point a struct of type a struct point and another instance which is P2, right? So we are using the setters here, because as soon as line 59 is actually executed and line 63 is executed, the default constructor is called, and that default constructor sets the value of P1 के जो attributes हैं x and y, उनकी values को 0 set कर देते हैं और P2 की values को भी 0 set कर देते हैं, and then we can like use the setter function or use the dot notation, straight away dot notation, to actually set the value of x. So 60 and 61, I mean in both cases you can use the setters. I mean there is no harm in using the setters in both cases. This is just to illustrate. Okay, so let me just see. अच्छा चले हम इसका जो है ना वो setter ही use करते हैं to set the value. We will not use let's say the dot notation that we have, so we'll set the value to 10 here, to 9 here, और इसी तरह से यहाँ पे we can set the value let's say y is 2, and we'll eliminate this. Okay, so we are using the setter functions to set the values, right? तो setter functions को हमने use किया to set these values. So these two values have been set. Now the next thing is that we need to call this function of type let's say point, which is the add function. So we'll call this add function, which would add these 2 points together, right? Okay, so let's just call these. Write down a small piece of code to actually call the add function here. Okay, so we define a new point which is add value. I mean the addition of the value. I mean instead of add value we can also write down P3. Let's say कि P3 हम यहाँ पे लिख देते हैं, और यहाँ पे हम ये कहते हैं कि जी जो भी इस function की जो return है that actually gets stored in P3, और add value की जगह हम P3 लिख देते हैं. Again we write it P3 so that you can easily understand that okay, this is the third point or the third struct type that has been generated in this particular case, right? So this almost completes our code. Okay, so this completes our code, and now let's run this. So I'll just go through these lines. So we declare a new point type P3, which would be the addition or the new struct that has been defined that would add P1 and P2 in the way we have defined earlier. here is a call to this function, which is add a function, and it takes in instances p1 and p2, which have been initialized earlier from line 59 to 65. And then after this function has been called, we are just printing the values of p3. So here we have set the value of x for p1 as 9 and y for p1 as 18 and x for p2 as 1 and y for p2 as 2. So the answer we are expecting should be 10 and 20. So 9 adds to 1 and 18 adds with 2 to get the value 10 and 20 respectively. So let me just run this code and see that what is the result. So here you can see that okay, the results are being shown, and the first value which you get is 10 and the second value which you get is 20. Okay, you can just run it with another value. Let's say I can put this is equal to 10 and I can put this is equal to, and I can change this to 20, and then I can like run this code again, and you will find a different set of values that you will be getting. Okay, right. So this is what it requires in order to define a function that whose return type is also a struct. So line number 48 is very important here. So यहाँ पे आप जैसे आप अदर फंक्शंस डिफाइन करते हैं आप अदर डेटा टाइप्स रिटर्न टाइप्स की, इसी तरह आप जो है पॉइंट या स्ट्रक्ट रिटर्न टाइप के साथ भी फंक्शंस को जो है वो अप्लाई डिफाइन कर सकते हैं. दिस इज़ हाउ दिस एक्चुअली वर्क्स. राइट. Okay, our next discussion is about access modifiers. Access modifiers, that means that these access modifiers change the scope of the variable. These variables that define the scope of the way you can actually redefine the scope of the variables is not that difficult. It's quite easy. Generally, you need to understand that whatever you define using struct, everything is global. That means that everything is public. It's accessible from anywhere from in your program. But in some cases, if you want to secure a certain variable, or if you want to secure a certain function, or if you want to secure some data member or a function, you can declare it in a way कि the scope becomes limited. That means कि उसकी accessibility को आप limit कर देते हैं. That means कि main program से आप उस particular variable को आप access नहीं कर सकेंगे. So in order to, and this is done through the access modifiers. ठीक है. And let me just show you again with the help of a very simple example कि ये access modifiers जो हैं वो हम कैसे define कर सकते हैं. Okay, so I'll just take in a very simple example here. We have defined a function here which returns the value of a variable which is a, and here I can define integer a as a data member of this struct. I am calling this struct as my struct. ठीक है, और एक फंक्शन मैंने डिफाइन कर दिया, और फिर मेन प्रोग्राम में I can actually access this variable. ठीक है जी. Okay. So I'll just comment on this for a while. Okay. So here I'm defining a struct, my struct, which is defined as y, or because a is a data member, and I'm trying to access this data member from the main program. Okay. So इस data member को from the main program I'm trying to access this data member, and let me just put this equal to 10 so that it actually prints some value as a result of this. ठीक है. So I haven't really declared anything else. इसमें मैंने कोई कंस्ट्रक्टर वगैरह भी इसमें डिफाइन नहीं किया. इट्स अ वेरी सिंपल प्रोग्राम. एक जो है वो वेरिएबल है और एक फंक्शन है जो कि उसी वेरिएबल को रिटर्न करता है. ठीक है. So this is primarily the getter function in a. Okay, so let me just run this program. Okay. Okay, so this function has been defined, and now line number 25 where we are accessing this variable which is a. So we don't have any problem here in accessing this variable at all. ठीक है जी. So this is perfectly fine. Let me just run this code and see what is the outcome of this. You can see A has been accessed without any problem. Now I'll make a very small change here, and I'll make I'll limit the scope of A. Okay. And I can actually do that by using this keyword which is called private with a colon sign, using this particular word. So this is primarily using this keyword private. Private is the access modifier. Okay. And now if I run this program, you will see that it gives you an error. So that means that it says that my struct में जो A है, that is a private data member within this context. So that means that it cannot be accessed directly from the main program. Okay. So it gives me an error. So, but let me try to access this variable through the function f. So f returns a, right? F returns a. And here what I've done is that I'm using y.f. So I'm calling the function. And you can very easily see here that this function which you have here, this function that you have defined here, that function is inside the struct. This function has been defined inside the struct. So let's try to call this function. Okay, let me just run this code. I have commented out line number 26 because A cannot be accessed. Let me just run this, and it again says that function is also private in this particular case, so you cannot access this. Now what's the reason for that? The reason for that is that this function has also been defined under private. Okay, so private colon उसके बाद I'm using this function. ठीक है. So this function also becomes private. So what I can do here is that I can remove this function from here, ठीक है, and take it before the keyword private. ठीक है. If I take it before this keyword private, in this case this function is no more private. ठीक है. That means this is no more the scope of this function is not like limited anymore. By default it becomes public. That means that it can be accessible from anywhere from the main program. ठीक है जी. So that can actually be done. So let's see whether it works or not. ठीक है. So let's just run this, and here you see that this works. The function is public in nature. ठीक है? The function itself is public. That means कि उसका scope limited नहीं है. It's public. The scope is public. That means that it can be accessed from anywhere. ठीक है? लेकिन an important thing that you need to note here is कि a function that is public, if that returns a private member of a struct, the private member can be retrieved in the main program. The private member cannot be retrieved directly in the main program, but it can only be accessed through a function. Okay? It can only be accessed through a function. Right? So a private member, data member, or a function cannot be accessed from anywhere outside the struct. That is the important thing that you need to remember. Okay? A private member can only be accessed by, and we are talking about the data member here, can only be accessed by a function that is part of that struct and is public. If it is public, that function, then if you call that function in your main program and that function contains a private member, then the private member could be accessed. So a direct access to a private member is not possible, and indirect access, that means through a function, is possible. Now we'll elaborate on this concept when we'll discuss classes. So this keyword here, private, is primarily representing what? This is representing access modifier. So we have modified the access of a data member by declaring it private. ठीक है जी? Okay, so this is a very important concept. Okay, so there is another keyword that is used, which is also an access modifier, that is called public. Okay, so let's suppose कि मैं इस function को वापस यहाँ पे ले आता हूँ. So now it becomes private because this falls under the scope of this private access modifier. लेकिन अगर इससे पहले, if I write down public here, right, and then run this program, this keyword public on line number 19 brings this function outside the domain of the private modifier, access modifier. Okay? So you have actually modified. So public and private can actually be defined in inside structures. Okay, so this is a very important concept, and it needs to be understood very clearly. So you can see that now the program runs without any problem, right? So this actually completes our introduction to these access modifiers that we have discussed, private and public. Just to reiterate, private member of a structure means that it can only be accessed within the structure, not outside the structure, right? And that too by a function. If you want to access a private member in the main program, you will have to do it through a public function, right? Otherwise you can't really directly access it. Okay, so that's it. We'll continue our discussion on some other concepts, inshallah.